set in 3 similar triangles. Go ahead and give these warm-ups a try before checking it. All right, determine whether the triangles are similar. So number one, let's check to see they have the same angles, because to be similar, they have to have the exact same angles in a triangle. So they all have the same angles. Since this is 67.4 and this is 67.2, 22.6, 22.6, we know we're good. So now what we have to do is we have to set up our proportion to see if they're all proportional. So be careful with your sides. Make sure you're setting them up correctly. 5 would go with 3, and then 12 would go with 7.2, and then 13 would go with 7.8. Okay, do your division, and you get 1.6 repeated for all of them. So we can definitely say that they are similar. 2 pentagons are similar with a scale factor of 3 to 7. The perimeter of the larger pentagon, 1, 2, 3, 4, 5, and then we've got a smaller one over here, and this is 3 to 7. The perimeter of the larger pentagon is 42 feet. What is the perimeter of the smaller pentagon? So we know the proportion is 3 to 7, and that must be equal to, we don't know the perimeter of the small one, but we do know the perimeter of the large one is 42. You can cross multiply here, or you can easily see that 7 times 6 is 42. So you'd have to multiply the top by 6 to get x is equal to 18. So you would get 18 feet there. Ways to show that 2 triangles are similar. So by definition, show that all 3 sets of corresponding angles are congruent and all 3 sets of corresponding sides are proportional. So what does that mean? Well, we've got some stuff that we can use. So you can use angle-angle similarity. So if you know that 2 angles are similar, we know the third one's similar too, because they have to equal 180. And that's called the angle-angle similarity. You can also use the side-side-side similarity. If you know that all 3 sides are proportional, then they're going to be similar. And you can also use side-angle-side similarity. So if you know 2 sides and then the angle in between, then you know it must be similar. And don't forget that this is our similar sign, that little guy like that. Determine whether the triangles are similar. Okay? So go ahead and take a look and let's see what we have so far. Well, we have 42 congruent to each other. And I could use angle-angle if I know another angle. Well, let's look at the first triangle and find what A would be. So 58 plus 42 and minus that away from 180. And we end up that this must be 80. And since that is congruent to that, we can use the angle-angle and say that they are similar. And be careful, because if it says write a similarity statement, you actually need to use a similarity statement, and this one would be triangle ABC is similar to triangle EDF. And remember, you've got to have these guys line up correctly. Determine whether triangles are similar. If so, write a similarity statement. So using some stuff that we've learned in the past, we can say that's congruent to that by vertical angles. That's congruent to that by alternate interior angles. So we do know by AA that triangle QPX is going to be similar to triangle NMX. So here again, determine whether they're similar and then explain your reasoning. So we can set up a proportion and side. So we know that this angle is congruent to that angle. So now we have a side angle, side, side angle, side. So we have to see if the proportions are equal. So when we're doing this, 4 would go with 6, and 5 would go with 7.5. And I don't really like, it's hard to tell with decimals, so if you move those both over, once you get 4 6 equal to 50 over 75, you can reduce this one to 2/3, divide these both by 25, and you get 2/3. So by side, angle, side, we know that triangle, remember, be careful with this, triangle ABC is similar to triangle DEC. Okay, so determine whether the triangles are similar. If so, write it. So we've got two different triangles going on here. We've got a small one, and then we have this bigger one. So be careful, you've got to add these sides together to get it. We share an angle right here, so we already have, we can look at side, angle, side. So we can do 10. So if we look at the small one first, 10 would go with 25. We've got to add those sides together. 10 to 25, is that equal to 12? Add these sides together to 30. Reduce them both down, see if they're equal. You can divide these both by 5 to get 2/5. And you can divide these both by 6 to get 2/5. So we do know they're similar. Write a similarity. Triangle MNP similar to triangle MRS. Okay, it just steps it up a little bit, but it's the same thing that we've been doing. So given that RS is parallel to UT, RS is 4, RQ is x plus 3, QT is 2x plus 10, UT is 10, and we need to find we're looking for RQ and QT. So RQ, like the actual length of it, and then QT, the actual length of it. So we know that they're similar, so we can actually do this because we know this is congruent to that, and that's congruent to that. So by angle, we know they're similar. So when we set this up, got to be careful with what sides go together. XR, so see how we go from 1 to 2? 1 to 2 would go there too. So when we're setting it up, it's x plus 3 over 2x plus 10, and that must be equal to, well then we know that 10 and 4 must go together. We started with the smaller one, so that's equal to 4 over 10. So go ahead and cross multiply. Remember to distribute in, so this would be 10x plus 30 equals 8x plus 40. Subtract 8x from both sides and 30 from those sides, so you get 2x equals 10. So x must equal 5. Be careful, we're not done because it wants us to plug it back in. So if we plug it back in, 5 plus 3, this side would be 8. And then 10 plus 10, this side would be 20. Josh wanted to measure the height of the Sears Tower in Chicago. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow is 2 feet. Then he measured the length of the Sears Tower shadow, and it was 242 feet at the same time. What was the height of the Sears Tower? So basically what this is setting up is a similar triangle because if you're looking at it at the same time, the shadows are going to be proportionate to each other. They're going to be similar. So we don't know the height of the Sears Tower, but we do know the shadow that it cast was 242 feet. We know the height of the light pole was 12 feet, and we know that the shadow was 2 feet. Not drawn perfectly. So then we can set up a proportion. So 12 over 2 must be equal to x over 242. Solve it however you want. We can just do cross multiplication. So when we do that, we get 2x is equal to 12 times 242. Let me get my calculator. Is 2,904. And then you can divide by 2. So x would equal 1,452. So go ahead and try these. Push pause, try them, and then we will go over. All right, so for that one, you should have gotten B. Try to find your mistake if you did. Okay, next one's up. You should get A for that one, A. Go ahead. B, should have gotten B. Give this one a try. Okay, for this one, we should have gotten A. Go ahead and give this one a try. This is the shadow one. Be careful. It's 5 feet 6 inches, so we would write that as 5.5 if we wanted to write it as feet, because 6 is half of 12, so you get 5.5. Give this one a try. All right, so for that one, we should have gotten A. And then here is just kind of a rundown of everything that we went over today.